Hello, business calculus students. What we have here is the same problem that was on the last video. So what I want to do is I want to find local max and mins. But I want to do this somewhat differently. What I want to do now is I want to do this using the second derivative test. So I've already gone through all the steps here. We kept those up for finding critical points. Let's use the second derivative test. Whoa, apparently I can't spell. Now with the second derivative test, of course, what we need is the second derivative. So we've got the first derivative up here. We need the second derivative. That will give us 6x minus 12. Now, when you're using the second derivative test, what you're doing is you're plugging in your critical points into the second derivative. So let's go with x equals 0. F double prime of 0, if I plug that in, will be negative 12. Okay, that is negative. So if my second derivative is negative, my graph is concave down. So that means I'm at the top of a hill. My point looks like that. And so that means what I have here is a local max. If I plug in 4, then f double prime at 4, plug 4 into this, I get positive 12. That is greater than 0. A positive second derivative means that we are concave up, so that my graph looks like this. I'm at the bottom of a valley. I must be a local min. So that's how the second derivative test works. Notice that it gives us the same answer as the first derivative test, and it's just a question of which technique you would like to use. Sometimes it's easy to take the second derivative and apply it. Sometimes you'd rather use the first derivative test. By the way, knowing these things about concave up and concave down with the sign of the second derivative, those are good quiz questions. So if I give a quiz, I might give something on that. But that's a good example of the second derivative test.